Now, all programs run sequentially. So for example, what does that mean? It means instruction 1 is first, and then instruction 2, and so on. So I will do this instruction first, and then I'll do this instruction. Then I'll do this instruction. So I will never go 1, 2, 3, 4, 5, and then skip to 9. Not in the way programs are actually done. It always goes in order in which they are typed in. Now, flow control means control the order in which program instructions are executed. Let's look at that. So we got two main controls. We got skipping instructions and we got repeating instructions. So let's look at skipping instructions first. So normally you'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. But in skipping instruction, maybe when you got to 4, maybe you want to skip over that and go straight to line 7. That's a skip of instructions. Repeating instructions. So instead of going 1 through 9, maybe you want to take instructions 3, 4, and 5 and just keep repeating that in a loop. That means you're repeating instructions. Now, how do you skip instructions? You use the if, else instruction. So if this, else do this. So if this is true, do that. If that's not true, do this. Let's see how that works. Sounds like a tongue twister, but let's see how that works. Problem. Let a user enter a number, grade, and a letter grade is outputted. So that's the problem we're going to solve. Now, here's the instructions. Here's the program. Enter a number grade using the input, and it goes into variable G. If G is greater than equal to 90, L equals A. Notice the quotation marks. If that's not true, else L equals to F. And then you end the instruction. So from here to here is our skipping instruction. So depending on what happens, either you do line 3 or you do line 5. And so if somebody types in 95, L becomes A, and then it will just skip these instructions and go straight to line 7, and it'll print the grade is, and L will be the value of, what do we say, 95? 95 at this particular point, right? Now, what if somebody types in 70? What's going to happen? 70 goes into G. Is 70 greater than equal to 90? The answer is no. So it's going to skip this instruction and go straight to L equals F. And then it's going to print out the letter grade is 70. All right. Let's ramp this up a little bit. Let the user enter a number, grade, and a letter grade is outputted. So this time we added more if statements. In particular, we're using the, look at this, else if condition. That allows us, gives us more options. So let's type in that number 70 again and see what happens. So if somebody types in 70, it goes into variable G. If G is greater than or equal to 9, is that true? No, that's not true, so it'll skip this instruction. Else if G is greater than or equal to 80, is that true? No, so it'll skip that instruction. Else if G is greater than or equal to 70, now that is true, so it will do this instruction. It'll say L is equal to C. C is in quotation marks again, so L is going to take on the value of C. Now, because this was true, it's going to skip all of these instructions and go straight to the end and print the grade is 70. Now, suppose somebody types in, say, 80. Let me get a better one. Suppose somebody types in, say, 81. So 81 is G. Now, if G is greater than or equal to 90, is that true? No, so it's going to skip that. Else if G is greater than or equal to 80, that is true, so L equal to B, and guess what? It's going to skip all these instructions. It's not going to even do them. All right, and then it's just going to go straight from here all the way down here to the bottom, and it's going to print the grade is 81. Now let's say we typed in, say, 50, for example. So 50 is G. If G is greater than or equal to 90, that's not true, so it's going to skip this. Else if G is greater than or equal to 80, that's not true, so it's going to skip this. Else if G is greater than or equal to 70, that's not true, so it's going to skip that. Else if G is greater than or equal to 60, that's not true, so it's going to skip this. And then this is the last condition. So if none of these was true, this else means that if none of this happens, then the last condition is what is executed. So it skipped all these at the top, and it said else equal to F. And so now at this point, it's going to print L, the grade is 50. Another problem. Ask a user to guess a number between 1 and 100. If they guess the output, print you win. If they guess incorrectly, output you're guessing too high or too low. All right, let's see how this works. So here's the code for the guessing game. I got a variable, num is equal to 25, that's number to guess. G is equal to input equals guess a number between 1 and 100. If G is equal to num, notice this double equal sign. I gotta say double equal sign, it means compare. If the variable G is equal to the variable num, print you win. Else if G is less than num, print too low, else print too high. So that's a simple guessing game. So they're trying to guess the number 25. And if they type in, say, 20, for example, 20 is not equal to 25, so it won't do that. 20 is less than a num, which is 25, so it will print that, and it won't print that. If they guess 40, for example, this is not true, this is not true, but this is true, so it'll print too high. So let's look at repeating instructions. For loops and while loops are two ways we repeat instructions. For loops looks for a fixed number of times, loops for a fixed number of times. The while loop loops for an unspecified number of times. For example, print the numbers between 1 and 5 to a computer monitor using a for loop. So here's the code. For I equals 1 colon 5, print I. So this is going to print 1, 2, 3, 4, 5. It's going to start at 1, and it's going to end at 5. And the variable I is going to print out. So every time through the loop, I changes, it's incremented to the next level. If I did the same example with the while loop, I had to set it up a little bit different. I had to set an initialization variable, I is equal to 1. Then I'll say while I is less than 6, do this. So it'll print I, and it'll say I equals 1 plus 1, and then it will end. So it'll go, let's look at this. So first time through, I is equal to 1. That is true, so it'll keep going, so it'll print 1. And then it'll add 1, I plus 1, so I is 1, so add 1 to it, it makes I 2, and it goes back to the top. So now I is 2, 2 is less than 6, so it'll keep doing this, so it'll print 2 next. And then here it'll say, okay, I plus 1, I is 2 now, so now I is 3. Go back, I is less than 6, which is true, so it'll print out 3. And this will keep going until it prints out 5, and then 5 will be I plus 1, make that 6, and then this will be not true anymore, so it will just skip to the end and it will end the actual program. Alright, let's see how this works. Ask a user to guess a number between 1 and 100. If they guess correct, output you win. If they guess incorrectly, output if they were too high or too low, but give them 5 times to guess. When you got to give them a specific number of times to guess, what we're talking about is a for loop, because remember, for loops are specific. Alright, let's look at this. So it's exactly the same code. Here's the same code from last time. So now we got to put a loop around this. So what part do you think we're going to loop? Let me go back. So what part do you think we're going to loop? So what part do you think we're going to loop? We're actually going to loop the guessing part, and so all this needs to be looped. Let's see what that looks like. All right, wow. So well, look at all this code, Amos. Yep, it's a lot of code now. First code, set the number to be guessed. Next code, I got a variable called game that lets me know whether or not the game is won or lost. We'll a little bit more about that variable later. Next, I set the for loop. The for loop goes from 1 to 5 because I'm trying to do it 5 times. I use a variable I as my variable to increment. Then you see the indentions, right? So this lets you know that everything from 4 on down to 13 is part of this for loop. So you guess the number between 1 and 100, enter in the G. If G is equal to num, print you win. If they win, I change the variable game to 1. And then this is very important, this word break. This break is going to actually break this for loop out. Alright, so if this is not true, then it's going to look at the second statement, else G is less than num. If that's true, it's going to print too low, and what's going to happen is it's going to keep looping again. And this will loop 5 times. The only way for this thing to not loop or to stop is if it goes into this part of the if statement, which causes it to break. Now, once this for loop is over, it's going to go to line 15, either because of the breaking or because you did it 5 times. And then it's going to check the variable game. If the variable game is still equal to 0, it's going to print you lose, and it's going to tell them what the number was. Now, if the variable game is not 0, which means that it had to change right here, and it's the only place it could change, then these statements will not be executed at all. Alright, let's do this exact same thing. Let's do this with while loop. And for the while loop, we're going to keep the while loop going until somebody wins. So this is an infinite loop. So num is equal to 25. Game is assigned to 0 first. So while game is equal to 0, remember the double equals again, right? That means compare. Do all this stuff. So it asks you to guess a number, goes in the variable G. If it's equal to it, it'll print you win, and it'll print the game is equal to 1. Now, if it did that, when it went through the loop again, it will notice that the variable game had now changed to 1, so it will end the loop and the program will be over. Now, if this part is not true, it'll check this one. And if this is true, it'll print too low to let you know you was too low, and it will go back to the loop, and the variable game is still equal to 0, so it will keep going. Now, if this is not true and this is not true, by default, it'll just tell you it's too high. And then it will go back through the loop, and it'll check the game variable and see that's still equal to 0, and it'll keep going. The only way for this loop to stop if this game variable is equal to 1. And the only way to get this game variable equal to 1 is that somebody has to type in a value of G that's equal to the number 25. And that's how you do a while loop. All right, the next thing I want to talk about is called functions. And this is grouping instructions together to perform a particular task. So look at this function. Remember our line function? So I got a function, it's called line int. It's going to take in 4 parameters, M1, M2, B1, and B2. And when you take those parameters in, it's going to use them, it's going to compute the X, and it's going to compute the Y, and it's going to return the values of X and Y. So this now is a function. This is a container that holds code. You pass some stuff into the function, and you get something out of the function. In this case, you pass in a slope of 1 and 2, and the y-intercept, and you get out the intersection point. Now let's see how you use this. So as remember, this is our function, and this code down here is our line intersection code from last time. So everything's the same. So ask for the slope for line 1, ask for the slope of line 2, ask for the y-intercept, ask for the y-intercept line 2. Now you take these variables and you plug it into the function, and then the function does this code and returns X and Y to you, and then you print out the value of X and Y. So it's basically, it takes that stuff in the container of line int and it forms, so it's almost like replacing the code here and putting it there without you have to rewrite it. Alright, so that ends our lecture on the programming layer.